hydrogen bonding. So hydrogen bonding is basically the electrostatic force of attraction. Okay, what do we mean by electrostatic force of attraction? Means it is the force of attraction which is there in plus and minus, right? Plus charge and minus charge is electrostatic force of attraction between ions. So between partially positive, this is partial charge, okay? It's if it is completely separated, okay, it will have complete plus one. But if it is bonded, it is partial positive, okay? Partially positive H atom and an electronegative atom of other material. H atom should be connected to fluorine, oxygen, and nitrogen because they have tendency to pull the electron. And if the hydrogen atom is connected to them, the H will have partial positive charge and it will get attracted by the other partially negative atom. Let me show you how it happens. The most common example of the hydrogen bonding is water. Clear? So in water, actually, you have this. So oxygen is more electronegative. What is the, tell me first 4 or 5 electronegative atom, if you remember.
Fluorine.
Yeah, fluorine, oxygen, nitrogen, chlorine, right? These are
Yes.
the 4 most electronegative elements. Okay. So if the hydrogen is connected to these electronegative elements, these electronegative elements have tendency to pull the electron pair toward themselves like this. Like this, the electron pair is not in the middle, it gets shifted towards the oxygen. So slight positive, this slight is small delta and positive. Slight positive charge will come on the hydrogen because the electron of the hydrogen electron cloud is moved towards the oxygen. Same is the case here also. Slight positive charge. Got it. Oxygen will acquire slight negative charge. Got it.
Yes.
Is it clear? So this is the scenario for the water.
Yes.
And there is not only a single water molecule. There are many water molecules, as we know. So the other water molecule may also be having the similar kind of polarization of electrons. Got it?
Yes.
So that its hydrogen may have acquired partial positive and the oxygen partial negative. So now this positive and negative will start attracting with each other. And this is called hydrogen bond. Is it clear? This dotted line is the example of hydrogen bond. Is it clear or not?
Yes, sir.
Or in short, we write it as H bond. Clear?
Yes.
So, though this is not as strong as the covalent bond, but it plays a very important role in deciding whether the molecule is going to be solid or what is the boiling point. Okay, is it clear? So, hydrogen bonding, only the hydrogen atom directly connected to electronegative atom participate in hydrogen bonding. Why is it so? Why not any hydrogen atom can participate? Why only the hydrogen connected to oxygen, fluorine can participate? What's the reason?
Can pass.
Because of the charge. Because it will not have positive charge otherwise. Got it?
Yes.
Is it clear or not?
Yes.
It will not be sufficiently positive otherwise. You need to have electronegative element.
Mm.
Then only the hydrogen will have the positive charge. Right? Otherwise, it will not be positive enough. Okay. And
Okay,
will
sir.
not feel the attractive force. So this is clear. Hydrogen bonding. Hydrogen bonding can be within a molecule or it can be between two different molecules. Okay. Inside a molecule also it can happen. Is it clear? And
Yes, sir.
it is also visible to means it is also between two different molecules. So it is within the molecule or between two different molecules in the water.
Mm.
Yeah, it is within the same water molecule or between two different water molecules. Okay, it is between two different. This is one water molecule. Okay,
Yes, sir.
this is another. So it is between two different molecules. So that is called intermolecular hydrogen. Intermolecular hydrogen bonding means what?
Mm. The negative and positive are
Yeah, within a same molecule or between two different molecules. Intermolecule between two different molecules.
true.
Got it? Yeah,
Yes, sir.
between two molecules. Okay, it is intermolecular hydrogen bonding. So the boiling point of the water is high. Okay, it is 100 degrees. Okay,
Yes.
because of this intermolecular hydrogen bonding. And it also has its effect on the structure of ice. Okay. So why ice is lighter than water? Why ice floats on water? These
Mm.
are the lone pairs. Okay.
Okay.
So lone pair are the pair of electron we have seen which do not participate in bonding, and the H plus get attracted by this negative charge. Okay, is it clear, Nabila?
Yes, sir.
So what happens in ice? Ice is a crystalline solid, we know. Okay. ice is actually less dense than water. That's why it floats. Why it is less denser than water? Getting my point? Because why ice float? We see iceberg floating in the sea, okay. But why? Because it is density is less than water. Density of ice and water. Water is more. And ice is solid, but it is less dense. So what reason will you give?
The lone pair operating.
Actually, in a solid, the water molecules are arranged in a particular pattern. Okay. And the pattern is such that it enables the water molecule to participate in the hydrogen bonding because they must participate in the hydrogen bonding. Okay. But that lead to lot of empty space present. In liquid, they keep moving, they fill that space. Okay. But in ice, there is a lot of empty space. Is that clear?
Yes.
So it is called open. Lot of empty spaces are there. It is known as open cage-like structure. And lot of empty space. So if there is lot of empty space, what will happen to the density?
It
will
decrease.
It will decrease. Yes, absolutely correct. The density will be less. Okay. Lot of empty spaces, less density means ice is lighter than water. And if it is lighter than water, it will float on it. Okay. And what is the reason? What is actually causing the water molecule to arrange in a particular array? What is the actual reason? One word, due to hydrogen bonding, the water molecule are arranged in a particular manner. Is it clear?
Yes, sir.
And that leaves a lot of empty spaces within the water molecules because they want to form the hydrogen bonding. And this leads to lighter density of ice. Okay, that's why ice flows. Ice expands. It needs more space. It is lighter. Lot of empty space. Okay, is that clear? Let's move on to the
Yes,
next example. This is very important example. You must know it is because of hydrogen. The root causes hydrogen bonding. Okay. The next example is will be coming in class 12th also, as it is about to start. Okay, in few months. So we will start preparing for class 12. Okay. The preparation starts from 11th only. Okay. There are some concepts which are common between class 11th and 12th. Okay. So this is water molecule. Okay. And this is, can you tell me if you can recall which molecule is this? This is an organic compound.
C2H4OH.
Yeah, this is yeah, C2H5OH exactly. So which molecule it is? It is a very common molecule. Ethanol, alcohol. Okay. Yes. So you are able to recall, that's good. So now, which is the boiling point? If you compare, water has a boiling point of 100 degrees. Pure ethanol is applied when injection, during the injection, you must have noticed that they apply some pure ethanol rectified spirit. It is known as on the skin to make it infection free. That's why we feel very cool. Okay, because the alcohol evaporates very quickly. So why it evaporates? Boiling point is low. That's why it will evaporate. But why the boiling point is lower? Why the water has boiling point 100 degrees and why the alcohol has the boiling point of only 78 degrees?
The hydrogen bond.
Yeah, more number of hydrogen bonds. Okay.
Mm.
In water because there are two H. Okay. In alcohol part, this carbon containing group will not participate in hydrogen. Is it clear or not?
Yes, sir.
That will not be a part of H bond. Okay.
Okay, sir.
So boiling point, more the hydrogen bonding. In HF also it is there. HF. Chlorine is the most electronegative element. HS plus, Fs minus, HS plus, Fs minus. Got it?
Yes, sir.
Yeah. So HF is the only liquid among all HFs. Yeah, Maha, am I audible? Good evening.
Yes, sir.
So just started with the hydrogen bonding and hydrogen connected to electronegative atom. Okay, acquires positive charge because electronegative atom try to pull the electron density. Got it?
Okay.
Electronegative atom acquires negative charge. Got it?
So the little structures you drawn, those are electron clots over there?
Yeah, these are the lone pairs. So this is the water molecule. Just I was discussing that in the water molecule, H acquired delta positive charge because it is connected to oxygen, which is electronegative. So the oxygen acquired negative charge, partial negative charge.
Yeah.
And because of that, there is a force of attraction represented by these dotted lines. Okay. This is known as hydrogen bonding. And just I was discussing with Nabila that in why the density of water is low. Okay. Why the density of ice is lower than that of water? Because in solid ice, the water molecules are arranged. It is a crystal, so water molecules are arranged in a particular manner. You can see it. They are around that structure.
Yeah, they're closely connected.
Yes, they are packed in a particular direction. Okay. So the lone pair is in along the OH bond because they want to get involved in the hydrogen bond. This is partial positive, negative. Partial positive, negative. Partial positive. So as a result, there is a lot of empty spaces in ice. But in water molecule, the water molecule can fill that empty space. Okay, in liquid water. So water has more density, but the ice has less density because this hydrogen bonding, due to this hydrogen bonding, it leaves a lot of empty spaces within the ice. That's why the ice floats on water. Its density is lower than water. It is ice and the water also has very high boiling point. Alcohol has lower boiling point because alcohol there is just one H. The ethyl group, alkyl group doesn't participate in hydrogen bonding because this is not having electronegative carbon. Okay, carbon is not sufficiently electronegative. Only the hydrogen connected to chlorine, oxygen, and nitrogen, three most electronegative elements, participate in hydrogen bonding. Among all HX, HX means HF, HCl. HBr, HR. HF is liquid. Why?
And all of them liquid form?
No, they are not liquid, they are gaseous. But you may be wondering, Nabila, you might have seen in the school also, as Ma is telling. You may be wondering that you might have seen in the school in the liquid form and filled in bottle. Got it? But that's not true because they are gases, but it is very difficult for the students to handle the gases, so they are mixed into water. They are highly water soluble also.
So they're diluted.
Yeah, diluted in aqueous. That is HCl aqueous, not the pure HCl. Pure HCl is gaseous. So why HF is liquid? While HCl, HBr, in spite of being heavier, more molar masses, okay, they are gases. There may be something which may be holding the HF molecule together more strongly.
More
it clear?
force of attraction.
Yeah, more. But what is that force of attraction? And it's arising because of the partially positive H plus connected to chlorine and H minus. Got it? Is it clear? So
Yes.
this is hydrogen bonding, H bond. So you will say this is due to H bond. But what happens to HCl, HBr? They will not have that much H bonding, or that will be not be called as H bonding because only because in HF it is very strong because fluorine is the most electronegative element. So that will bring the sufficient positive charge on the H, and that enables it to attract the being attracted by the or attract the F of other F atom of other molecule more strongly. That lead to hydrogen bond. Got it? Clear or not? Any doubts?
Please.
So similarly, ammonia molecules can also participate in hydrogen. What's the formula for ammonia?
H3.
Yeah, NH3. NH3 also can participate in hydrogen bond. So H should be directly connected. Okay. To the nitrogen. How you will represent? This is partially negative. The lone pair is negative. It carries a negative. Just put the H of another molecule in front of it. Okay. Is it clear?
Yes. Yes.
Hydrogen bonding can be between two molecules, as we are seeing here that it is between different molecules. We can see here, or within the same molecule. So H bonding can be intermolecular or intramolecular. Intermolecular and intra between two molecules. And intra means within a single molecule. The best example is you know phenol. Have you heard of it?
Yeah.
Okay, benzene with the OH. Okay, this is used as a household disinfectant. Okay, to clean.
As an acid, right? To clean.
Yes. So if you put a nitro group, okay, opposite to the OH in the benzene ring. This is the nitro group, okay? This opposite position is known as para position. This is known as para nitrophenol. And you can put the nitro group just adjacent to the OH group. This is phenol, okay? The benzene ring with the OH, and you put a nitro group just besides the OH. This is known as ortho position. So this is known as ortho. These are the names. Don't worry about the names as we are going to discuss them in details. Orthonitrophenol. Okay. Yeah. So this is the OH and O minus of the NO2 are very close to each other. Because the NO2 is of the ortho position. These two positions are known as ortho. These positions are known as meta. And this is para. Orthonitrophenol, the OH of the phenolic group can be attracted by the O minus of NO2. And this results into some extra interaction within the same molecule. Okay, that is called intramolecular because it is hydrogen bonding is happening, but not between two different molecules. This is happening within a same molecule. Okay, intramolecular hydrogen orthonitrophenol. Is it clear?
Yes, sir.
But in this case, the OH and the nitro group are far apart. They are too far. So this OH cannot participate, cannot come near to the nitro group because they are just opposite, other side. So what happens? This OH group get attracted by the nitro group, but not of its own molecule, but of a different molecule. Got it? Is it clear? It is from a different molecule. So this is a new molecule. Is it clear?
Yes,
Ma,
sir.
am I audible?
Yeah.
So this is a new molecule plus minus, okay. So this is between different molecules. So this is known as intermolecular hydrogen. Intra means within a molecule, inter means between different molecules of same type or different type. Is it clear?
Yes, sir. So
Got
what does
it?
intra mean?
Pardon?
What does intra mean?
Intra means within a same molecule. And inter means between two different molecules or between different molecules. This hydrogen bond is not within a molecule like it is found here. Can you see? This is an example of intra. The OH is interacting within its molecule with NO2 because that was adjacent to it. But in this case, the position is such that that will not allow intramolecular. That will allow intermolecular between different molecules. Okay, is it clear to everyone?
Yeah. Yes,
So
sir.
now tell me where the boiling point will be higher, where it will be difficult for us to boil the two. Will it ortho nitrophenol need to be heated to a higher temperature to boil? Will it be easier for us or will it be difficult for us? If it is difficult, we need to heat it by more amount, okay, higher boiling point. I want to ask boiling point of orthonitrophenol and paranitrophenol. Compare. I'm not asking you the value. I'm just asking the order of boiling points of ortho O
Actually,
nitrophenol.
more for the para-nitrophenol because more bonds are there.
Yeah, actually, the paranitrophenol, all of these molecules are holding each other tightly. Got it?
Okay.
They are holding each other. Okay, this edge is connected. This O is taking bonded to other OH other. So likewise, this all are being connected to each other. If they are being connected to each other, it will be difficult for us to boil them and separate them in vapor. So the boiling point is going to be higher for para-nitrophenol. Orthonitrophenol. So always remember boiling point decreases due to intramolecular hydrogen bonding. Is it clear or not? Intramolecular hydrogen bonding decreases the boiling. There are more details in different functional group, and we are going to discuss as we are going to cover different chapters. Got it?
Okay, sir.
In mostly in organic, it will be very much useful. So and this intermolecular edge bonding increases the boiling. Can every H participate in a hydrogen bonding? What's the answer?
Second repeat.
Can every hydrogen atom of any molecule can be part of hydrogen bonding? Or is there certain characteristic to whom it is attached so that it can participate? Hydrogen atom attached to which type of molecule can participate in hydrogen bonding? Yeah. Hydrogen bonding can be only the hydrogen which is directly linked to electronegative atom can participate in hydrogen. Is it clear or not?
Yes.
Okay, like methane. Can methane participate in hydrogen bonding? Is it sufficiently electronegative? Carbon is not sufficiently electronegative. Got it? So, how you will remember the hydrogen atom connected to fluorine, oxygen, nitrogen. Okay, they are the most electronegative element. They only can get that can participate in hydrogen. Got it? Most of the cases. Clear? Hydrogen bonding, intermolecular hydrogen bonding increases the boiling point as well as it increases the water solubility also. Clear?
Yes, sir.
So I hope this is clear. So this will be very much important in your class 12. So let me start with the organic chemistry. Okay, we will do first chapter of organic chemistry, and then after that we can start with the equilibrium. Okay, is it clear? So we are going to start with basic principles of organic chemistry. Okay, and it is there in the second book. Okay, but be very careful regarding organic chemistry, that it is there uh, other chapters. Okay, other chapters, if you miss them, like whatever the chapters we are having, you will not get affected. Your learning will not get affected much, okay, in class 12. But if you miss organic chemistry, okay, because it is interrelated, okay, it is very much interrelated. All the chapters, okay, are interrelated. So it will affect your learning in class 12 also. Okay. So what I request is, organic chemistry, the chapters can be different, but they are more connected to each other. The whole chemistry is connected. Okay, it's not like redox. Okay, redox actually, every time you see the redox action, but that much knowledge you have that oxidation happening or reduction happening, addition of atom. But organic is very much related. All the reactions are very much integrated throughout class 11th and class 12. Okay. So we are going to start with the basic principles, okay, of organic chemistry. Hmm? Yeah, pardon? Or, yeah, Nabila, am I audible? Hmm. Yeah, you were telling something.
Your voice isn't audible, sir.
Voice is not audible.
No, it is. It was lagging.
Okay.
Hmm.
Now is it clear?
Yes, sir.
So organic chemistry is very much integrated. Okay. That's what I was trying to explain. So this is there in the second book's organic chemistry, some basic principles and techniques. Okay. So first of all, organic compound, you know what are organic compounds? Yeah, Maha, what are organic compounds? You are quite familiar from your class 10th also. Getting my point or not?
Yeah. Like
So what?
carbon compounds, right?
Yeah, and they are the compounds of carbon. Clear?
Yeah.
So compounds of carbon and their other uh, compounds in which the carbon is linked to oxygen, nitrogen. Okay, they all come under the organic chemistry. Study of carbon and its compound.
Like glucose.
Yeah, glucose, fructose, right? Absolutely correct. Okay, all the daily life we have organic chemistry everywhere. Okay. All the fabrics which we are wearing, either the natural fabric like cotton, which is a polymer of glucose, okay, silk, which is a polymer of amino acid, okay, or synthetic fibers, they are also organic. Petroleum is organic. Medicine, the molecules are organic molecules. All the in our body, enzymes, DNA, our whole body has organic molecules within it. Okay, the plants made up of organic. So it is the chemistry, organic chemistry is basically the chemistry of living things, basically. Got it? So all the molecules, polymers are there, plastics, rubber, they are all organic molecules. So carbon and its compounds. Initially, it was thought that only the organic molecule can only exist in living organism. They cannot be prepared in the lab. Okay, and that was called vital force theory. Okay, long back when people were not aware of it, they
It
used
can
to.
be made in lab.
Yeah, they can be made in lab. So actually, Wohler synthesized the first molecule in lab. Wohler synthesized from ammonium cyanide. It was heated and changed to urea. This was the first compound which was prepared in the lab. Okay, and so that vital force theory was proved incorrect by this experiment. Okay, it was just imaginary. Got it? And after that, lot of compound. Now we can synthesize lot of complicated compounds. Lot of very all the molecules can be synthesized in lab, right? So Wohler synthesized the first organic molecule, which was urea. Is it clear to everybody?
Yes.
Yes.
The next is uh, you need to why you must have studied this. Okay, just I would like to say that why there is a separate chemistry for just one element, carbon. Is it clear? Separate chemistry just for one element. And all the 117 elements are studied together in inorganic chemistry, and that one element is studied as organic chemistry, and the whole branch is dedicated. Why? What's the reason?
Maybe because it's so vast.
Yeah, because there are so many compounds. So vast, so many compounds, so you need a separate branch of organic chemistry to study them. Yes. So why carbon has so many compounds?
Maybe because it's not stable in its own single form.
No, it is stable in its single form also, like diamond,
But
graphite.
that's the allotropic form.
Yeah, allotropic form. But not only it is stable with itself, it is also stable in coal. That is also carbon. Okay, coal is a carbon only. So it is stable on its own as well as with other compounds also.
Because we learned in the 10th grade that the carbon always wants to make bonds with other to make itself stable.
Hmm. Yeah, so carbon. So one thing is sure, which we discussed, and that is carbon form a large number of compounds. And that's why a separate branch is needed to deal with the compounds formed by the carbon. Is it clear?
Yeah.
Carbon form a large number of compounds, very large number. And no other element can match carbon when it comes to forming of different compounds. Clear or not?
Yes, sir.
But what's so special about it? Why carbon formed large number of? It has two properties, okay, which are responsible for the formation of large number of. One is the carbon is tetravalent. What do you mean by tetravalency? And the other property is catenation. Hmm. Yeah, Nabila, what do you mean by tetravalence?
4 bonds can be formed.
Yeah,
by
4 bonds can be formed. Okay, so carbon can form 4 bonds. Okay, you can see like this. And this is a very important check. Okay, this is a very small thing, but a very important check to know whether you have made a structure correct or incorrect. Always remember, Nabila, what you will remember that the carbon makes
4
how
bonds.
many 4 bonds, right? There can be a double bond. If there is a double bond, 4 bond, just 2 more single bonds will be needed. Okay, look at the carbon at a time. There can be a triple bond. If there is a triple bond, I need just 1 more hydrogen to fulfill its tetravalency. There can be 2 double bonds. Okay, carbon is tetravalent. Got it?
Yeah.
Yes, sir.
Always. And if it is tetravalent, these are sigma bonds. They are, and the carbon is sp3 hybridized. Is it clear?
Yes.
And in this, what is the hybridization? Just can you tell me of the carbon? You need to count only the sigma bond, single bond, and lone pair. Lone pair, you do not have lone pair. Okay. So how many signal bonds are there? How many sigma bonds are there on this?
Mm.
Hmm?
4.
Sigma, 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 and this is pi. Okay. I will do it once again. Carbon is there. Carbon in the ground state doesn't have 4 unpaired electrons. Carbon in the ground state 2s 2p. Okay, and you need to first make arrangement of 4 electrons so that you can because though there are 4 valence electrons, but you need to show them unpaired so that you can make them participate in the bonding. So this is the excited state. ES. Is it clear?
Yeah.
Yes, sir.
So these are different orbitals and they are not going to form the bond so well. So what we do, we mix them together to hybridize them. Okay, you need to count the number of single bonds. Okay, the double bond is there, double bond 1 sigma and 1 pi. Okay, this is sigma, sigma. You need to count only sigma bonds. Okay, the rest of the bond which are formed in addition to single bond are pi bonds. So there are 2 pi bonds and 1 sigma bond. For hybridization, you need to count only sigma bond and the lone pairs if it is present. Clear? So in methane, you have 4 sigma bonds. The hybridization is sp3. Clear or not?
Yeah.
So all the four orbitals become sp3 and they try to form the bond with hydrogen. So that's how you have methane getting. And suppose if you try to form the ethene, ethene is having how many sigma bonds? Each carbon. How many sigma bonds are there?
Carbons.
Hmm? 3 sigma bonds. Okay, the bond total bonds are 4. That will always be there. But the sigma bonds are 3 because this one is sigma, another
One
is
is
pi. Right, Ma? So how it may form this is carbon is. So this is 3 sigma bond means you need to mix 3 orbitals S and only two of the p orbitals you need to mix or hybridize. You need to keep one of the orbital as it is unhybridized. So carbon is sp2. How sp2 carbon will look like? The 3 sp2 will look like a fan. Okay, the blades of a fan at 120 degree. Okay, they are in a plane. Okay, sp2, sp2, sp2. And what happens to this p orbital, which is unhybridized? That will be perpendicular to the plane of 3 sp2 hybrid. Is it clear? Any doubts in this? But there are 2 carbon in ethene. So the other carbon also is doing the same thing. Is it clear? Nabila, is this clear or not?
Yes, sir.
Maha?
Okay.
And so these sp2 orbitals which are facing directly each other along the line joining the 2 carbon atoms, they overlap in a head-on fashion. Okay, along the axis joining the 2 carbon. This is a sigma bond that we know, already discussed that. Similarly, hydrogen come in and overlap in a head-on fashion to form a sigma bond, sigma bond, sigma bond. Got it? Sigma. Got it? Is it clear?
Yes, sir.
So you have, but for hybridizing, you need to count the carbon atom on. You need to count the sigma bonds on one carbon atom only. Okay. But still, we have made 3 bonds. One bond is yet to be made. And which is that bond? That bond is this. So there are 2p orbitals which contain unpaired electron. This one. They are yet to be bonded. Okay, they are parallel to each other, perpendicular to the plane. So they are bonded in a sideways manner. Is it clear or not? To form the pi bond.
Yes, sir.
So pi bond, the electron density is above and below the moleculars. The sigma bond is along the line joining the 2 atoms. Okay, this is a double bond, it cannot rotate. Pi bond cannot rotate. Sigma bond can be formed by pure atomic orbitals and it can be formed by hybrid atomic orbital, but the pi bond is generally formed by unhybrid atomic orbital. This P, it is known as P pi P pi. Okay. Is it
Yes.
clear? So what about the triple bond? What is the hybridization of carbon in ethine? So pick any of the carbon atom. Try to figure out how many sigma bonds are there. So how many sigma bonds are there? This is sigma bond, okay, and there are 3 bonds, okay, only one will be sigma. Got it? Total 3. Absolutely correct. But for hybridization, you need to look only for the sigma bond present on a single atom, okay. At a time, you need to focus on one carbon. Got it?
Okay.
Total bonds you need, you may be asked to count the total number of bonds. For finding hybridization of a particular atom in a molecule, you need to count the sigma bonds on that particular atom. Got it? Not everywhere. Is it clear or not?
So 2.
Yeah, 2 sigma bonds are there. So what is the hybridization of this carbon? You need 2 of the atomic orbitals of the carbon to mix together and form 2 sigma bonds. You can take sp. Got it? This is sp hybridized carbon. Is it clear? So if you try to look how it may have happened, we can easily draw. This is I'm directly writing the carbon in the excited state. As you already know and studied in the chemical bonding. I need to make 2 sigma bonds. Both should be uniform. So I will pick S and P together. Mix them. S will also become SP. P will also become SP. And they will become, each of them will be known by the name of SP. If this is SP, this is SP. There is a small lobe also. After the hybridization in the lobe start looking whether it is S or P, it start looking like a balloon with electron density on one side. Here, you have 2 unhybridized p orbitals. So just first let me draw the unhybridized p orbital. One is like this. Green one and the blue one. Blue one is actually like this. Okay. It's coming towards us. These are the pure p orbitals. Look, they have 2 lobes. If it is a hybrid, you have just one big lobe. Is that clear? So this is another sp hybridized carbon. As it is approaching, okay, what is happening? Which bond is this formed by the white lobes?
Yes.
And this is which bond? Formed by overlapping of the white lobes. This is
Pi bond.
no, the white lobes. sp. How they are
No
overlapping?
bond.
Head on or sidewise? White lobes head on. Got it? They are overlapping. Is it clear?
Yeah.
So this is a sigma bond. Got it?
Yeah.
This is sigma bond formed by the sp-sp. Nabila, is it clear or not?
Yes.
There is a hydrogen. Okay, that hydrogen atom is going to come and overlap axially with this. Is it clear? So
Yes,
this
sir.
is sigma bond formed between the sp and s of hydrogen. Same is the case here also. This is also sigma bond. Each carbon has made two bonds as of now. Two bonds are yet to be made. And they cannot now, because the orbitals are like this. And all of the orbitals cannot be like this. Okay, only one pair can be like this. Okay, others should be like this. So how they are going to overlap? They are going to overlap in a sideways manner. Is it clear?
Yes.
This is how it is going to work. And these are the pi bonds. There are two pi bonds. Clear or not? The pi bonds are perpendicular. Okay? One is like this, another electron density is like this. Okay, the green one is like this, okay, and the blue one is like this.
Yes.
They are in the different. But this is very, very important, not only for this chapter, for all the organic chemistry which we will be discussing in class 12th also, right? So be very careful about it. I hope it is clear, Maha, Nabila. Any doubts in this?
No.
No, sir.
So the first thing is you need to tell me the number of sigma bonds and pi bonds. Okay. Is it clear? That is the first question which will be asked. So find the ratio of sigma bonds and pi bonds. This is my first question. And now you are very well familiar with it. Clear? And also indicate the hybridization of the carbon atom. Clear or not?
Yes, sir.
So this molecule is a very famous molecule. Can you tell me the name of it? Hmm. You might have studied in 10th if you remember, or if you don't remember, not a problem. Just try to recall, quickly recap what is going to be the name of this. Hmm.
Pencil.
Yes, benzene. Absolutely correct. This is benzene. And Nabila, what is the formula? Yeah. How many carbon atom are there? There are 6 carbon atom and 6 hydrogen atom. C6H6.
This is
Yeah, absolutely correct. How many? What is the ratio of sigma bond and pi bond in this? Just tell me quickly. You can
Maybe
see
4:1.
total sigma bonds. If you are asked for the molecule, count the total sigma divided by total pi bonds in the molecule.
Sigma bonds are 12, and then the pi bonds are 3.
Sigma bonds are 12. Yes,
So
exactly.
4.
Yes, absolutely correct. So there are 12 sigma bonds. Nabila, is it clear or not?
Mhm.
And 4 pi bonds. So the ratio is, sorry, 3 pi bonds. So the ratio is 4. Okay.
Okay.
Next question. Normally, the structure which I have written. I am also telling you one more thing. Okay, the structure which we have written. This is known as detailed structure form. And this you may be drawing in your class 10th also. That's how you must have drawn it.
Yeah.
But it is a time consuming process because from now onwards in class 11th and 12th, the molecules will be so big that it will not be possible for us to draw each and every atom, show each and every atom. Is it clear? No?
Okay.
Yes.
So what we do is, what we try to do is, we try to save time by writing condensed structural formula. Okay, like where you don't show all the bonds. Okay, just you show the carbon-carbon bonds. Is it clear?
Yeah.
This is the condensed structural formula, and it is now we realize that it is easy for us to write. But do keep in mind that the carbon make 4 bonds. And now we have the formula which will be used in all the upcoming chapters and lectures of organic chemistry in all the upcoming examination, whether it is CBSE, NEET, JEE, everywhere. Okay. And especially in the competitive examination, also you will see a lot of these formulas written in this way. The next formula is bond line representation. So bond line representation, what you do? You don't write the carbon and the hydrogen atom because that is obvious. Okay. Wherever the two line meet, listen to me very carefully. Wherever the intersection two line intersect, that is the carbon atom. Hydrogen atom, so the symbol C is not written. Clear? Hydrogen atoms are not shown. So bond line representation of benzene is going to be like this. Clear?
Yes.
So Nabila, how many bonds you are? This is the carbon atom. This is actually a carbon atom. But Nabila, how many bonds are visible to you on this carbon atom? How many lines you can see?
Mm.
Hmm? How many lines you can see on this carbon atom which I have pointed by arrow?
Two.
Hmm? 1, 2, 3, 4. How many
9.
lines? Hmm?
9.
No, on this, I'm talking about only this carbon.
Two. Three.
How many
Three.
lines are visible to you? Okay, 3. Got it?
Yes.
Why 3? Because you have that. This is the double bond. Okay, clear?
Yes, sir.
This is a single bond. Ma, is it clear or not?
Yeah.
But the carbon is tetravalent. So where is the fourth bond? Is the structure incorrect? The structure is not incorrect. It's the way to represent it. Okay. The fourth bond, if it is not written, it is hydrogen. Is it clear?
Yeah.
Yes, sir.
So hydrogen atom, it is obvious. So keep in mind that the carbon is tetravalent. Okay. So the carbon-carbon bonds will be shown by the lines where the lines meet that represent a carbon atom. The symbol C is not mentioned. Hydrogen bonds will not be shown. Neither the hydrogen symbol for the hydrogen atoms will be shown. Got it? This is known as
Yes.
bond length. Or a polygon formula or a zigzag representation also it is called, right? Other names are polygon formula or zigzag notation. But if you have other atom like chlorine, oxygen, nitrogen, is that clear? They
Yeah.
Yes, sir.
they must be shown by their symbols because otherwise how will I imagine that which element it is, whether it is chlorine, bromine, iodine? Got it?
Yes, sir.
Getting my point or not?
Yes, sir.
So very important to be comfortable with the bond line because now from now onwards you will have this structure only. Okay. Okay. So now I'm going to write a molecule, which all of you must have. You know, you are familiar with the smell of that molecule, and that is naphthalene. All of you are familiar with the naphthalene?
Yeah. Natural bonds.
Yes, sir.
Yeah, naphthalene bonds. We are aware it is an aromatic compound, has peculiar aroma, right? I am writing the structure in the bond line. You have to tell me two things. What is the molecular formula of naphthalene? And the ratio of sigma bond and pi. Is the question clear to all of you? So tell me quickly.
C10 H.
Hmm?
C,
How many carbon atoms are there?
10.
10 carbon atom. Absolutely correct. Ma, is it clear? 10 carbon atoms.
Yeah.
And how many hydrogen atoms are there? For that, you need to look for the tetravalence.
Eight.
And how many? 8. Yeah. You have one hydrogen here. Okay. 3 lines. 3 lines. So what is the other atom? Hydrogen, which is not written. Okay. Just to because it's obvious, that's why it is not written. It doesn't mean that you have to write it, but you should keep in mind. Okay.
So the ratio is 11/5.
Yes, we will come to the ratio also. Can I put the hydrogen here also? Is it correct?
No, sir. No, sir.
Otherwise, yeah, it is becoming pentavalent. Carbon cannot have 5 bonds. Okay. This carbon otherwise will have the 5 bonds. Okay. Is it possible? No. Got it? This is only C10H8. Got it? Yeah. Now we will come to the sigma bonds. So how many sigma bonds are there?
11.
Yeah, there are in the 6 and 3, 4, 5, 6 and 5. Okay. 11. No, actually, you might have calculated only these sigma bonds. Okay. What mistake you have made? Ma,
I
you might
forgot to count the hydrogen.
yeah. This is the common mistake, okay, which happens with each and every student first time when they try to figure out. Okay. So don't forget what is the lesson learning. Don't forget the hydrogen atoms. Okay. They are also sigma bonds, right? Maha, is it clear? Nabila, is it clear?
Yes, sir.
So that is correct 11, but 11 and 8. Why 8 is to be added because of the hydrogens? 19. And pi bonds are 5. Got it? 19/5. Is it clear? What is the
Yeah.
ratio? What is the ratio of what is the so not ratio? Ratio we have already calculated. What's the hybridization of this carbon atom in naphthalene? Sp, sp2, sp3, sp4. In naphthalene. So what's the hybridization? Check only one carbon. Got it? Not all the carbon atoms. Is it clear or not?
Mm.
Just one carbon. Hmm. What is the hybridization? Yeah, Maha, tell me.
SP.
sp2, absolutely correct. Navila, is this clear? Don't count the pi bond. Okay. And in other molecule, count the lone pair also, but carbon doesn't have a lone pair. So 3 sigma bonds. Count sigma bond and lone pair. If they are present, lone pair also need to be counted. Hybridization, for hybridization, count the bond on one atom. Okay. 3
Okay.
sp2. Navila, is this clear or not? So all
Yes,
the
sir.
carbon atoms are sp2 hybridized. Got it? Now, suppose if I write ethane or butane, how I write butane? This is butane. How many carbon atoms are there? Any idea? Just I hope you forgot. Maybe 4 carbon atoms. Okay, I will tell the nomenclature and all. Don't worry about that. Got it? So 4 carbon atoms. Look, they are all making single bond because it is ane. This is the detailed structural formula. Got it?
So there are only sigma bonds over here.
Yeah, only sigma bond. Each carbon is sp3 hybridized. What I can do, I can collect the atoms which are of same type together and write them as numbers, collectively as numbers, H2 and H3. This is condensed way of writing. Got it? Condensed structural form. Got it?
Yes.
And this is the bond line representation. It is known as zigzag notation because the carbon-carbon bonds, I can't write them like this. Okay. How somebody will know that how many carbon atoms are there if I just put a very straight line, or if there are 5 carbon atoms, make a longer line, or if there are 8 carbon atom, make much longer line. Okay, how will I know? Getting my point? If I put a straight line, for this is 1 carbon, right? This is another. This is the third. This is the 4th carbon. So each carbon-carbon bond is represented by a line. The other bond need to be started in a tilted manner. Okay, so that you can clearly see where the bond is ending and where it is formed. Got it? So
Yes.
this is the zigzag notation. Hydrogens are not mentioned. I hope you can see it. Clear? Hydrogen are not mentioned because it is a shorthand notation. So now you must be familiar with it. Is it clear?
Yes.
So be very, very careful, very, very important, because it is going to be useful for you for the upcoming year also. Okay, you will feel very comfortable if you are confident in organic. Okay, the other chapters, not much, you little bit, and that much you know. Okay, so let me end the class.